Good day to you all. Learner's Note is an online solution to encourage better ways of learning among our students. I am Anjana, your chemistry teacher. So let's discuss chemical reactions. We come across a lot of chemical reactions in our day-to-day life. We might not know that what is happening is a chemical reaction or not. For instance, the air we breathe in, the process of respiration is one of a type of chemical reaction. We take in oxygen, we take in food, the food is broken down into simpler form and we get energy and other products like carbon dioxide, water, etc. So that is an example for a chemical reaction. Similarly, the cooking of food, that is also a process of chemical reaction. What happens during cooking of food? We take vegetables or fruits, we put in all the spices and everything, and then we cook, we start heating. So what happens during heating? During the heating process, the properties of the vegetables or the fruits and the spices that you have put in mix and you get a result. So you given raw materials and you get products. So that process is what you mean by chemical reaction. So before you learn chemical reactions, there are a lot of terminologies that you need to keep in mind. The key terminologies involved in chemical reactions are reactants, products, catalysts, inhibitors, activation energy, law of conservation of mass, which is very important, then exothermic reaction, endothermic reaction, and the term precipitate. So let's look into all these terminologies. Let's see, first one is reactant. So the substance that you given to a reaction is called reactant. That is, the reactant will be present at the beginning of your reaction. Similarly, product is a substance that you get as an outcome of your reaction. That is, it will be present at the end of the reaction. And then you have a catalyst and an inhibitor. So sometimes in order for a reaction to take place, you need something called a catalyst. That is, you need to speed up the reaction. The speed of the reaction is not enough. It takes a longer time, or the rate of the reaction is very low. So in such a case, you use a substance called catalyst. So the function of catalyst is to speed up the reaction without actually taking part in the reaction. So inhibitor is something that does a function which is exactly opposite to that of a catalyst. Inhibitor is a substance that slows down a chemical reaction, whereas your catalyst is a substance that speeds up your chemical reaction. Then you have got something called activation energy. It is a minimum amount of energy that is required for your chemical reaction to take place. Then you have law of conservation of mass, which is very important. All the chemical reactions that is taking place in this world obeys law of conservation of mass, which states that mass can neither be created nor be destroyed. So that is one of the important law which is used for balancing your chemical equation. Then you have something called endothermic and exothermic reaction. You might have heard this terminology before, but still chemical reaction in which energy is released is called exothermic reaction, and the chemical reaction in which energy is absorbed is called endothermic reaction. And the last term that is very confusing for almost all the students is precipitate. So precipitate is a substance which is solid and it is formed in the solution when a reaction is taking place. So these are few key terminologies that you might come across in this chapter. Next, we move on to the type of chemical reactions. There are basically 5 types of chemical reactions. The first one is combination reaction. Then you have decomposition, displacement reaction, double displacement reaction, and the last one is redox reaction. Okay, now we will look into each equations or reactions in detail. The first one is combination reaction. In combination reaction, just like the term suggests, combination takes place between 2 reactants. So you have 2 reactants and you have one single product. So combination reaction can be defined as a process in which two or more reactants combine together to form a single product. So you can see an example, Na and Cl2. So you have sodium solid and chlorine gas. So these two combine together to form a single product, which is NaCl, which is your common salt that you use. Okay. Now, next comes the decomposition reaction. In decomposition reaction, what happens is the exact opposite of a combination reaction. In combination, we saw multiple reactants and a single product. But then in decomposition reaction, what you see is a single reactant and multiple product. A simple example for this would be decomposition of H2O. Water can be decomposed into hydrogen gas and oxygen gas. So here what happens is, from a single reactant you have multiple products, that is, you get the constituents of the reactant. So decomposition reaction again can be classified into photolysis, thermal decomposition, etc. In photolysis, what happens is, you have a reactant and you have sunlight passing to it. So when the energy from the sunlight hits onto your reactant, and that can lead to a chemical reaction. So during that reaction, the reactants are converted into products. You have one reactant and it is split into multiple products. So that is what happens in photolysis. Similarly, you have another one which is thermal decomposition. In thermal decomposition, what happens is, you provide heat energy. So when you provide heat energy, that energy is taken up by the reactant and the molecules are being split into its constituent elements. So that is what you mean by decomposition reaction. Next, you have a displacement reaction. Here you can see the reaction depicted as AB plus C giving AC plus B. Here you can see there are two reactants and two products. The speciality of this displacement reaction is that a higher reactive element will displace your lower reactive element in your reactant side. Okay, so you can see that your reactants are AB and one of the other reactant is C. Here C is more reactive compared to your B. So what happens? Your C is displacing B. So you get the product as AC plus B. So you can see an example which will make you understand better. So here you have two reactants, zinc and an acid, which is HCl. Okay. So when you have zinc and HCl, zinc is a more reactive component compared to hydrogen. So what happens? Zinc will displace hydrogen and hydrogen will be another product that you get. So here you will get the product as zinc chloride and hydrogen. Here you can see zinc is coming and sitting in the position of hydrogen and hydrogen is left out. So that is what happens during a displacement reaction. Now you have the next reaction, which is double displacement reaction. In double displacement reaction, you have two displacements taking place. In other words, you can say that there is an exchange of ions taking place in your double displacement reaction. You can see the reaction here, AB. You have reaction AB, reactants AB and CD, and you have products AC and BD. Here what you observe is, your B is exchanged with D. So B will come and sit in the position of D, whereas D will come and sit in the position of B. So you get the product AC and BD. So here basically there is an exchange of ions between the reactants and you get two products. There is another name for the double displacement reaction, which is nothing but precipitation reaction. Why it is called precipitation reaction is because you have two products and one of them would be solid. You get a precipitate out of the reaction, so that is why you have double displacement reaction, otherwise known as precipitation reaction. Next, you have the last reaction, which is redox reaction. In redox reaction, what happens? You have both oxidation and reduction reaction taking place simultaneously. Now you need to define what an oxidation reaction is and what a reduction reaction is. There are two definitions for both oxidation and reduction reaction. To understand oxidation, we will analyze what is happening during oxidation. You have two reactants as usual, you have two reactants and you have two products. Now, oxidation can be defined as a process in which oxygen is gained by the substance or electron is lost by the substance. So, if initially your reactants would be having an oxidation state of 0, it will not be having any charge. But then once the reaction proceeds and you get a product, you have a charge. So, that charge is because of the oxidation reaction or reduction reaction that is taking place. So, when oxidation is taking place, you have a gain of oxygen or a loss of electron. So, here A is initially in the oxidation state 0 and it will lose an electron and it gains a positive charge. So, a substance which is having a positive charge is because of the loss of electron. So, A from its oxidation state 0, it will become A plus, which means it has lost an electron. So that process of losing an electron is called oxidation reaction. Now, the same way you can define reduction reaction as well. In reduction reaction, what you see is you gain an electron or you lose the oxygen that you have. Okay, so here again you can see in the reactant you have B with an oxidation state 0. But then once the reaction is proceeding, it has a minus charge. When does a substance get a minus charge? When it gains an electron. So B is undergoing reduction because it is changing its oxidation state from 0 to -1 by gaining an electron. Otherwise, you can say reduction is a process in which you lose oxygen. Now we will see an example for redox reaction. Here you have carbon and an iron oxide reacting to form iron and carbon dioxide. This is a very simple equation, and from this equation, just by seeing itself, you can identify where oxidation and reduction is taking place. Here you can see the reactants are carbon and iron oxide. So yeah, you have carbon and iron oxide. Here carbon does not have any oxygen and the oxygen is contained in iron. So the product that you get is iron and carbon dioxide. Here carbon is gaining the oxygen and it is becoming carbon dioxide. So that process is called oxidation, the process in which you gain oxygen. Similarly, iron oxide had oxygen and that oxygen is lost and it forms a product iron, which is solid. So that process is called reduction. Here what happens? Oxidation reaction and reduction reaction are taking place simultaneously. That is why it is called redox reaction. Redox reaction is a reaction in which oxidation reaction and reduction reaction take place simultaneously. So these are the 5 basic kinds of reactions that you can see in chemical reactions and equations. Okay. Next, you can again classify reactions into 2 types. One is reversible reaction and the other one is irreversible reaction. As the name suggests, reversible reaction is the one in which you can reverse the reaction. That is, you can get back your reactants from the product. But irreversible reaction are the reactions in which you cannot get back your reactants. That is, once the reaction is done, there is nothing you can do about it. You will have to deal with the products. You cannot go back and get the reactants. Okay. So reversible reaction is a process that can be reversed in order to obtain the initial state of the system, just like I said. So reversible, usually when we write a chemical reaction, we simply put an arrow which is unidirectional. But then when you are writing a reversible reaction, what you have to keep in mind is that you have to use this symbol when you are writing a chemical reaction. That is, you use a double-headed arrow. That indicates that reaction can take place in both directions. So there is an equilibrium between your initial state and your final state when a reversible reaction is taking place, and it takes infinite time for completion. That is very important because both the reactions, that is the forward reaction as well as the backward reaction, is taking place simultaneously. To take an example, you can maybe say the melting of ice and freezing of water. That is an example for reversible reaction. And then you have irreversible reaction. Here you do not have an equilibrium because once your reactants are treated, you get the products. There is no going back from product to reactant. So that is why we use a single-headed arrow here. Yeah, we use a single-headed arrow here to represent a irreversible reaction. Okay, and it takes finite time. That is, within a specific time period, you will get the product. So for irreversible reaction, you can maybe talk about cooking of food or respiration. All those processes are irreversible reaction. And we have an activity for reversible reaction and irreversible reaction, which we will see later. Now we are going to demonstrate the different types of chemical reactions. There are 2 types of chemical reactions that we discussed, reversible and irreversible. So first we will see how a reversible reaction is taking place. For that, you need copper sulfate, spatula, test tube holder, spirit lamp, a test tube and a test tube stand, and also a beaker containing water. Now first we have to take the test tube and put some copper sulfate powder into it. Now we light the spirit lamp. Now you take the test tube holder and hold the test tube with it. Now slowly heat the test tube. As the copper sulfate loses its water of crystallization, the blue color will start turning to white. You can see that the blue crystals has completely turned into white color, and you can see small water droplets on the side of the test tube. After a few seconds, what you can do is take a dropper and fill it with water and slowly add it to this white color copper sulfate. You can observe that the copper sulfate changes its color back to blue. This indicates that the reaction is reversible. Dear students, now we have seen how a reversible reaction takes place. In this reaction, what you saw was initially you taking a blue color copper sulfate and heating it. Once this copper sulfate loses its water of hydration, it becomes white in color, and adding water to the copper sulfate again changes the color from white to blue. Now we will demonstrate irreversible reaction. For that, you need a magnesium ribbon, a spirit lamp, and a holder for holding magnesium ribbon. Now we hold the magnesium ribbon using a holder. Now slowly try burning the magnesium ribbon. Now we can see that the magnesium ribbon has turned into white color powder. This indicates an irreversible reaction. Here, this white powder cannot be turned back to your magnesium ribbon. Learners not believe in learning concepts through doing experiments. We have plenty of such experiments related to your syllabus. Please watch our videos. Visit us at www.learnersknow.com for exploring a whole new world of learning with fun. I am Sanjana, your chemistry teacher, signing off.